Earth, our home planet, a small blue dot drifting in the tremendous, inestimable sea. Here lives everybody you at any point knew, every human who at any point experienced, every story that was at any point told. It's where our process begins. Yet, as we zoom out past our environment, past the moon, past the recognizable planet and the sun, we leave on an incredible mission, a journey to grasp the true size of our universe. As we leave Earth's embrace, the primary marker on our astronomical journey is the moon, around 384,000 kilometers away, a distance so huge that, if you were to drive a vehicle at a steady speed of 100 kilometers each hour, it would take you over 160 days to reach it. From this lunar vantage point, Earth appears as a delicate circle of blues and greens, suspended in the dark void of space, a sight that places our world into a humbling perspective. This is Earth as seen from the moon. As we continue our outward excursion, the next achievement is the Sun, lying roughly 1 astronomical unit away from Earth. This unit, comparable to around 150 million kilometers, is the standard gauge for distances in our planetary group. Imagine this: light, traveling at an astonishing speed of 300,000 kilometers per second, requires around 8 minutes and 20 seconds to travel from the Sun to Earth. If you somehow managed to travel this distance in a commercial jet, flying at 900 kilometers per hour, it would take you around 19 years. This gigantic distance is a clear indication of the vastness of space, even within our own solar system. The Sun, a fiery behemoth, provides life-supporting energy to our planet from this incredible distance. Wandering past our home planet and its solar companion, the Sun, we set our sights on Mars, our mysterious red neighbor. Mars, at its closest approach to Earth, is around 54.6 million kilometers away. However, this distance can stretch up to 401 million kilometers when the two planets are on opposite sides of the Sun. To put that in context, traveling to Mars at the speed of a commercial jet would take upwards of 50 years. This tremendous spread of space between Earth and Mars has been a significant challenge for space exploration. The rovers and probes we've sent to the Red Planet embark on a journey that is not just far but filled with complications due to the constantly changing distances and orbital dynamics. As we journey to the outer reaches of our planetary group, we encounter Neptune, the distant ice giant lying roughly 4.5 billion kilometers from Earth. Neptune marks the edge of our solar neighborhood. Sunlight, racing across the vacuum of space, takes around 4 hours and 15 minutes to reach Neptune from the Sun. This staggering distance highlights the immensity of our solar system. Launched in 1977, the Voyager 1 space probe represents humanity's insatiable curiosity and our desire to explore beyond known boundaries. As of now, Voyager 1 has traveled for over 40 years, covering a stunning distance of more than 22 billion kilometers from Earth. It's the farthest human-made object from our planet, a silent wanderer in the cosmic sea. In 1990, at the suggestion of the renowned astronomer Carl Sagan, Voyager 1 turned its camera back towards Earth for one final photograph. This resulted in the iconic pale blue dot image. From a distance of around 6 billion kilometers, our planet appeared as a tiny, faint speck in the vastness of space. Sagan eloquently reflected on this image, emphasizing our responsibility to cherish and preserve our only home, a small dot in the gigantic universe. At the very edges of our solar system lies the Oort cloud, a vast theoretical sphere of icy objects. This distant cloud is believed to extend up to a staggering 100,000 astronomical units from the Sun, that's around 1.9 light-years, a distance so colossal that it's on the cusp of interstellar space. Scientists determine the boundary of interstellar space, known as the heliopause, where the Sun's solar wind is halted by the interstellar medium. This is where the influence of our Sun ends and the vast realm of interstellar space begins. The Oort cloud represents the final frontier of our planetary group, a boundary zone where the Sun's influence fades, and the grand journey into the galaxy truly begins. As we venture beyond the boundaries of our solar system, our next focal point is Alpha Centauri, the closest star system to our Sun, located around 41.3 trillion kilometers away. This distance is equivalent to over 276,000 astronomical units. At such epic distances, the AU, a unit so useful within our planetary group, starts to lose its practicality. As a result, astronomers use the light year, the distance light travels in 1 year, for interstellar measurements. Alpha Centauri is around 4.4 light-years from us. Considering our current space travel technology, a journey to Alpha Centauri is practically impossible. For instance, the Voyager spacecraft, traveling at around 17 kilometers per second, would take more than 70,000 years to reach this neighboring star system. This enormous distance emphasizes the vastness of space that separates the stars and highlights the challenges of interstellar travel. Our journey now takes us to the grand scale of our home galaxy, the Milky Way. Spanning around 100,000 light-years in diameter, this massive spiral galaxy is home to many billions of stars, each potentially hosting its own planetary systems. Within this enormous structure, there's a small bubble known as the human radio bubble, extending around 100 light-years from Earth. This bubble represents the farthest extent of human influence in the universe, the range of our radio and television transmissions into space. Beyond this bubble, it may seem as though humanity never existed, as our signals haven't reached any civilizations living in the majority of our universe. The size of the Milky Way is so immense that our entire written history is but a whisper in the cosmic breeze, invisible beyond this small bubble. As we leave the Milky Way, we enter the vast, almost inconceivable realm of intergalactic space. Here, galaxies float in the infinite ocean, separated by astounding distances. Our galaxy is part of a small cosmic neighborhood known as the local group, a cluster of more than 50 galaxies spread across roughly 10 million light-years. The local group is a diverse assembly, including not just spiral galaxies like the Milky Way and Andromeda, but also numerous smaller dwarf galaxies. The distances here are so vast that light from one end of the local group to the other would take 10 million years to cross. This scale dwarfs anything within our own universe, highlighting the immensity of the universe. Intergalactic space is a quiet expanse, a vast wilderness between the islands of cosmic light. In this enormous void, our galaxy, home to our entire history, is just a small dot among many, a single story in the grand cosmic library. As we expand our cosmic gaze beyond the local group, we encounter the giant Virgo supercluster, a massive collection of galaxy groups and clusters, including our own local group, encompassing a region of space around 110 million light-years in diameter, or 33 megaparsecs. The Virgo supercluster is a titanic structure in the universe, containing thousands of galaxies from over 100 galaxy groups and clusters, each with its own multitude of stars and planets. As we venture outward from the Virgo supercluster, we arrive at an even more awe-inspiring cosmic structure, the Laniakea supercluster. This massive assembly of galaxies, which includes the Virgo supercluster and extends over 500 million light-years, is our cosmic home on a grand scale. Laniakea, meaning immense heaven, in Hawaiian, truly lives up to its name, containing the mass of 100 million billion suns. Laniakea is a gravitational masterpiece, with galaxy clusters, superclusters, and countless celestial bodies bound in a vast web of attraction and motion. At the heart of Laniakea lies the Great Attractor, a mysterious region of space that exerts a colossal gravitational pull on the galaxies within this supercluster. In this vast spread, our Milky Way, the entire local group, and even the Virgo supercluster are just small fragments of this colossal structure. Laniakea provides a profound context for our existence. Within this immense supercluster, we are part of something far greater and more magnificent than we can fully comprehend. As we reach the limits of our cosmic exploration, we encounter the boundaries of the observable universe, an astonishing astronomical wonder, extending around 93 billion light-years in diameter. This raises a fascinating question: if the universe is only 13.8 billion years old, how can it be so vast? The answer lies in the concept of cosmic expansion. The universe has been expanding since the Big Bang, stretching space and increasing the distances between celestial bodies. But what lies beyond the observable universe? This remains one of the greatest mysteries of cosmology. Some regions of space are expanding away from us faster than the speed of light, placing them forever out of our view. Thus, the true size of the entire universe remains unknown and potentially infinite. The observable universe, vast as it is, may just be a tiny fraction of the entire cosmic expanse. We are left with the humbling realization that there may always be regions of space, entire worlds, and wonders that we will never witness as they retreat endlessly into the depths of the ever-expanding universe.